Hi, this video for example 6.2. So this example needs us to calculate or estimate the cost using hands methods and also factors that given in table 6.4. Okay, so the questions. A plant modifications have been proposed that will allow recovery of a byproduct. So the modification consists of adding the following equipments. The first one is distillation column with the specifications written here, and then YouTube heat exchanger with the area of 60 meter square, and then the kettle reboiler with specific area here. Then horizontal pressure vessels with volume 3 meter cubic, storage tank, two centrifugal pumps together with the driver power, three centrifugal pump with one driver power 1 kilowatt, but two installed plus one spare. So you have three, but two to be installed, and another one is spare. So estimate the install ISBL capital cost of the modifications if the plant is to be built from type 304 stainless steel. Remember, so all of these to be built using type 304 stainless steel. So we are using hands methods and also factors given in table 6.4. So the first step, we can do the calculations or cost estimate refer to the tables. We need to make sure the units to those required for the correlations and determine any missing design informations. So distillation column can be costed as a combinations of vertical pressure vessel and internal. So distillation column, vertical pressure vessel, and plus the tray inside, which is the internal. So for both pressure vessel, we need to know the wall thickness. So this one is like what you have done before, to calculate the wall thickness. How to calculate vessel wall thickness is according with SME, with the SME boiler pressure vessels. Okay, so is what you have done before. Okay, the design pressure of the vessel should be 10% above the pressure. So the design pressure is 11 bar, or roughly 1.1 times 10 power of 6 Newton per meter square. So the maximum allowable stress for 304 density at 260 is 12.1 kSI, or roughly 89 Newton per square. So means this value you need to assume certainly 260. Since like, does it have anything that mention the, I don't think so here. So we assume that this value. So assuming the well with fully rated craft, the well efficiency is 1. So we substitute inside the equations as what you have done before, then we get 0.0187 meter, then we plus 2, and then you say 20 m. 2 is a corrosion allowance, then it becomes 20 mm thickness. Then to calculate the shell mass, why you need to calculate shell mass? Because if you refer to the table, parameters available there is the mass of the shell. So now we calculate the shell mass using the of cellulose is 8,000 kilogram per meter cubic. So we use these equations to calculate the shell mass, which is the pi, and then the vessel diameter, which is we have it inside the specifications, and then the vessel length. So means here is the height for the station column. The thickness density is the metal density, which is here the stainless steel 304. So the for this column is 46,685 kilogram. For the horizontal pressure vessel, since we have horizontal pressure vessel in the list, we need to convert the volume into a length, the diameter. So we assume the vessel is cylindric with is a cylinder with the length is equal to times of the diameter. Then we can follow the same method for the column and to find the thickness of the wall, and then we can calculate the shell mass, which is the calculator here is 636 kilogram. You can later try this value whether you get 636. Okay, the first thing that we need to do later after we do all of this calculation of the mass, so we need to find the purchase equivalent cost by looking at the correlations in table 6.6. So from this table, okay, which is I already extracted from here to show you, okay, so we have a list of equipment, so make sure you find the correct one, because here it's not mentioned about the station column in the list, I believe. So what is things that what related to the station column is we need to have a column which is made from vessels, or we call it vessels here, and it's supposed to be vertical, right? Vertical, and in this case we consider vertical 304 stainless steel, because must be made by stainless steel in this case. So we take all of this value, right? So the calculated mass before this is how much, because shell mass, that's why we need to calculate. So okay, then we calculate the shell mass here is 46,685 kilogram. So the range vertical, yes, is it inside the range or more? It's still inside the range, so it's valid for us to use this A, B, and value. What is number 5 here? Note, not including head, spots, bracket, internals. Okay, so this only the cylindrical sections. So the station column shell, the cost is A, okay, plus B, and what is our mass, and then power of n. Okay, you can see this equation in the previous videos. Okay, so the station column shell cost 6,050 K, and then for horizontal pressure vessel cost, okay, this is horizontal, so we look at horizontal 304 stainless steel, and then the mass is 6 in this range. Okay, then we substitute A, which is 11,000, and then B is 63, and then the mass, okay, and then power of the N, so what we get is 26K. That one's for the column, distillation column and the vessels. Then we can do for remaining, go to the from the correlations based on carbon steel constructions, because here, for example, this ray, okay, is not mentioned here for stainless steel. Okay, so this one is all from carbon steel. Okay, look at the table. Okay, so the station column per 3, okay, so we are using here 3. Okay, actually there's no problem for you to use valve 3 or bubble cap, but we need to look at the description. Is it have mentions about this? Yes, this one is 50 CF3, so that's why we use the value of CF3. Okay, the value CF3, so this value, so we just substitute. Okay, 110 plus 380. Okay, this one is diameter. Our diameter is 3. Okay, look at the list. Is diameter is 3 meter. We directly take this one. Okay, so we assume that the tray have the 3 meter in diameter. So what we get is, by looking at the table, okay, so just substitute all of this, and we get this 2,855. Then we must multiply by 50, then we get 153K. Okay, this one for this station column. So remember, if you got this station column, you must consider 2 things. One is the vessel, the cylindrical, the tray. Okay, then for YouTube heat exchanger, okay, so we look at the list and then we find exchanger, YouTube, and then since this YouTube heat exchanger, okay, share and tube, okay, the area is 60, right, meter square, so in range, so we substitute A 4,000 here, and 46 times our area is 6 meter square, power of 1.2. Okay, same with the boilers. Okay, since this here in the list they have YouTube category boiler, which is the nearest one as category boiler here. Okay, then we check first the list, only mention category boiler, so we can pick up this YouTube category boiler, which is the area 10 to 500 meters square, and the category boiler surface area is 110 meters square. So we can use this range, okay, this value. So 35,000 plus 340, okay, 110 meters square, power of 0.9, then you get 48,000. Then for storage tank, conical head, because it's mentioned conical head, so we check again. Okay, storage tank, but it's not mentioned any whether it's conical head or what. But we check the volume. Volume is 50 meter cubics. So when we check the list, 50 meter cubics, 50 meter cubics is in this cone roof range. That's why we take this one. So means if like the detailed information is not mentioned which one, so we look at the capacity. So here the capacity is 50 meter cubics. That's why we pick this cone roof, okay, which is in the range of 10 to 4,000. So the same thing, so we do 5,000 plus 1400, and then what is the capacity in meter cubics, and also power of 0.7. Okay, let's say the storage tank, and then is give it to you in different unit. Okay, for example, liter, milliliter. So what you need to do is to convert to meter square. Okay, so whatever units that is not tally with the list, you need to convert it first. Okay, for example, this one is meter square, and then what is given here, okay, this one is meter square. Let for example here is meter. Okay, for the heat exchanger. So what you need to do to check the table, what is the unit used here? If meters, then you need to convert it first. Okay, so it's to avoid later on the wrong calculations, because the unit here is meter square. Okay, hope you understand. And for centrifugal pump, which is 3.6 meter cubic per hour, since like here, okay, pump and driver, we have only have three lists in the table: single stage centrifugals, and the rest is the motor, and this one is the third one in the power kilowatt. So you only have this one options from this table, right? This one, okay, single stage centrifugal. The unit is meter cubic per hour, so what you need to do is to convert it into liter per second, okay, to tally with this one. So it's after it's converted, so we know is 1 liter per second. So cost for each centrifugal pump here, so following this one, 6900 plus 206 times 1, and then power 0.9, we get 7100. Just multiply by 2. Okay, then it's come together with the electric motor. So how we know it's come together with the electric motor is we look at the list. Okay, so 2 centrifugal pump flow this one cubic per hour, then we convert to percent. Then this one driver power 500 watt. So this driver power 500 watt, we need to calculate it also for the cost. Cost for pumps is 14,200 done, and then the driver is cost is according to this one. Okay, the power is 50 kilo. So since like it's not mentioned with what start is rotations, proof monitor, or steam turbine, so look at the power at the range 1 to 2500, since the power of this motor is just now is 500 watt, right? So it's like it's near, so we pick this value, this one. Okay, so just get 220, and then cost for just multiply by 2 and go to this centrifugal pump. Same also, since the unit meter cubic per hour, then we convert it, it become 0.74 liter per second. Then since this range is too far from 0.6, and this one is the nearest range, okay, so we consider this as version motor. Okay, so find for 1 the cost each, this one, and then cost for 3 we just multiply these values okay, to become 21,100. And then the driver cost each, so we take this one, and then for 3 driver is 2460. Okay, note that pump and driver are at the lower end of the range validity of the cost correlation. Costs are small compared to other costs, and the error introduced is therefore manageable given the overall accuracy plus minus 30. So means we still have to use this because we lack of information. Okay, but so it will affect the cost estimations value. Okay, so we go to hence method. After we check the purchase equipment cost from this table, so we go to the hand methods because we need to use hand method and also the values, the tables, right? So because the question asks us, okay, estimate the cost using both hand methods and the factors given in table 6. These given in table 6 will come with the equations. Okay, and using hand methods means we need to refer from a table. Okay. So after we get this one, the purchase equipment cost, so we go to methods. So following hand methods, the install cost of the installation column is 10 4 times 6. Where this 4 come from? Okay, we check what is the values that we calculate previously. Okay, 0 0. Okay, so because we have these hand methods, so we need to refer the, okay, so just open the handbook. Okay, so we open handbook and we check hand methods. Where is hand methods? Okay, so this one material cost, this one is table 6.4, this one is hand method. So we look at here, installation column 4, installation factor 4. Okay, this one is installation factors. And remember, hand is refer to installation factors. So the installation column, the factors for the installation is 4. Okay, that's why here 4 times the purchase equipment. Okay, so we get 2600. So the cost of the to type 3O stainless by multiplying the average material factor from 6.5. Why we need to multiply these material factors? So if we go back to the first slide, which is questions, okay, the questions have clearly mentioned the modification. Okay, if the plant is to be built from type 304 stainless steel, that's why we need to convert to stainless steel. Okay, because the table previously that we refer, which is the purchase cost, okay, all is based on carbon steel unless is has mentioned otherwise. Okay, so that's why we need to include these material factors also. Okay, so this material factor. Okay, so the material factor is 1.3, table 6.5. We look at table 6.5. So this table 6.5. So carbon steel is 1, 304 stainless steel is 1.3. So it's correct, right? 1.3 and then times 143 here. Okay, cost for the 3. And here times the material factors, because if we relook in the table, right, it's already considered the stainless steel. Where is it? So the table is here. Okay, because previously what we refer to this vertical 304 stainless steel. Okay, stainless steel. So note 5 here. What is note 5? Okay, so it's as mentioned here, even it's not mentioned in the notes, but it's mentioned here. Vertical 304 stainless steel. So we directly take these values. That's why we don't have to convert it anymore. Okay, hope you understand this. Okay, this is the tray here. Okay, we look at the tray. If you look at the tray, okay, there's no mention this one's made from stainless steel. Even note number 6 is what? Number 6 is cost per tray. It's based on stat of 33. So it's nothing to do with material. So this one is all carbon steel. Okay, that's why we need the material factors to convert it to stainless steel. That's why here we cover the stainless steel then times 1.3. Okay, this then give a total cost of column plus these values, okay, 2600 plus 185,900, so it becomes 2790,000. Okay, for the distillation column. Then the insert horizontal pressure vessel. This one same also. Why we need to times 4, because the hand factor, the installation factor is 4. We check again whether it's correct or not. Okay, so we go to the hands. Where is it here? No, this one. Okay, so column 4, vessel 4. Okay, so vessel also 4. Then 4 times 2 26,000. Okay, so the install cost of the heat exchanger storage and carbon steel constructions is 3.5. Okay, so where you get this from? Okay, heat exchanger 3.5 installations. Okay, installation factors, and also storage. Okay, storage tank, where you get it from? Storage tank, miscellaneous equipment, because there's no mention any storage tank here. This one is compressor, this is column, fight heater, heat exchanger, instruments, so miscellaneous equipments 2.5 here is the storage tank. Okay, so we plus all together, so the cost in type 3 is 1.3. We need to multiply again with the material factors, because all of this information is all for carbon steel. Okay, okay, so same also with this pump. Okay, if we check for the pump we need to add the cost of the pump and driver before determining the install cost. Okay, only the cost of the pump need to be converted to stainless steel. Okay, pump only to be converted. Okay, driver no need. Okay, sorry. So for the first set of pump, okay, do the same thing, we 4 multiply by all of this. Okay, then for the second pump only 2 are installed. Okay, for the second pump need to be very careful, because it's mentioned here. Okay, it's a tricky part. 2 install plus spare. Okay, so 2 to be installed, another one is to as a spare. Okay, that's why here, okay, for the pump, okay, okay, so for the second pump only 2 are installed, the other one is a warehouse spare, so another one is spare. So if you see here, this is a calculation 1.3, okay, and then plus 820 plus 4 times 2 8 you see here there's a difference, okay, so this one only for one pump. Okay, one pump, this one for spare, this one have times 2 here. Okay, so this one is for the one that to be installed. Okay, so the total install ISBL cost of the plant is 10. All these total cost estimations, this is 70,600, 90,000. So this one for the column. Okay, so we take all the total and then we sum all the total, and what we get is the total install ISBL cost of the plant. Okay, it's around 3.5 million. Okay, so this one is the first order magnitude. Okay, so that's why the plus minus 30% accuracy. Okay, this one is a hand method. This is you are using these installation factors. Okay, and then we are using these material cost factors and also this equipment costs. Okay, and that, okay, that's all. Okay, so we continue with this equation 6.13 and 6.1, which is referring to table 6.4. If instead we use the factors given, then using equations, okay, for the cost for the exchanger. Okay, so this one is table 6.6. Okay, so we are using this table, okay, because in this table we having this CE, okay, which is the factors. So the factors is including equipment erections, piping, instrumentation and control, electrical, civil, structures, buildings, lagging and paint. Okay, so we're using equation 6.13. The initial cost for the exchanger, tank and pump is equal to all of this. Okay, so if you know this one, 30,300, okay, so we check again where these 30,300 come from. Okay, exchanger, not this one. Okay, this one is a okay exchanger. So this one, the cost actually come from this, which is equipment cost. Okay, so even we are using this table 6.4, all of this purchase cost, okay, is already calculated that using this table, which is 6.6 table. Okay, so this 0.8 and then 0.3, 0.3, 0.2, 0.3, 0.2, 0.1, we get it from this table. Right, where's the table? Okay, we're using this table. Okay, so now 0.3 is 0.3, 0.2. Okay, so we are referring to this table. Okay, 0.3, 0.3, 0.2, 0.3, 0.2. We will not consider 0.8 here, piping. Okay, there is some considerations here. Okay, we are not consider the piping. Okay, I see that this mentions anything about you no need to consider the piping, right? Okay, unless it's clearly mentions in the statements. So maybe here the designer just exclude the piping. Okay, because it's not taken in the calculations. Or wait, the piping is 1 plus 0.8. Okay, 1 plus 0.8 because piping is 0.8. So actually, what's the equations? Okay, we need to check what is the equation for this. Okay, let's open this slide. Okay, the previous slide. Okay, need to check where is the equations. Okay, it's take time. Okay, open the file. Okay, so because check what is the equations for this. Why suddenly what 0.8 is here? Okay, so check the equations. Okay, we'll come back. Okay, so it's take time to load this one. Okay, so where is the equation? Okay, so if you refer back to our slide, this equation is where is the equations? Location where's the equations? Okay, here I hope you can understand until this point. So if you something you not understand, you can ask me in the feedback or can ask me in the Microsoft team later or online. Okay, so where is it? Oh, where is the value? Where is the equations? So this is, yeah. Okay, factorial method. So if we see here, right, this is the equation. What is the installation factor for piping? Is FP. Okay, so we're having this one. This y is 1 plus 0.8, and then we change the material. Fm is the factor, the factor for the material. That's why 1.3. So this one is for tank and pump. So the install cost for the pressure vessel and pump driver, okay, we do not require a major conversion, so we split it. Okay, there's no 1.3 here. Okay, there's no 1.3. Okay, that one is for using the equations. Okay. Okay. So we go to stand slide. So in addition to this, we require the cost of trade intensity and the cost of the spare pump and so this one is add on. Okay. So we require the cost of the tray, okay, and the cost of the spare pump and the driver, because this one there's no need any material factors conversions, okay, because the tray is already sensitive and the pump no need. Okay, so the spare part and the driver. Okay, so the total install and spare cost, so we accumulate all of these values. Okay, so what we get is 2.9 million. Okay, plus minus 30% within the accuracy of the method. So now that although the answer obtained by two methods each well with the range of accuracy or other of the other, both estimates should be stated as being on 2007. Okay, so actually it's always important when we do the cost estimations and we get the total estimation. At the end we write which year, okay, which year basis we are referred to. Okay, so people will know. So this value is calculated based on the information or at which year. Okay, so by these calculations like this, okay, to me is like it's hard for us to like checking the values, which one calculated, which one is still not calculated, and we need to refer to the previous values that we calculate. So I prefer to have like something like this. So means by having table form like this, okay, it's like easy for us to look at what we have calculated before. Okay, for example here, I believe this one I already shared in CN. Okay, this one is the link is not work. I just type everything to show using tables like this. Okay, it's more like appropriate in terms of like we can see which one have been calculated, which one's not yet, right? And like this one is very clear to show the comparison between the hands methods here and also the equations that we are using, okay, which is equation 6.13 and the table 6.4. So at the end we can see that we can do like comparisons like this. Okay, so like this is more appropriate. Okay, it's more well organized. So in final exam you can write in this way in the table form instead of writing in the way of like in the textbook like this. Okay, so you know, for me I prefer this table is in this tabulated form. Okay, so I hope you understand these calculations. Let's say you're not understand, you can ask me later. Okay, I will online in the Microsoft team from 6:30 to 7:30. Okay, so we can have real-time chatting there. So I'm not going to do the live streaming or whatever. Okay, or else you can put your feedbacks or your comment or your any questions related to this calculation or this chapter in the Google form later on. Okay, and make sure you give the feedback before 9 p.m. today. Okay, so thank you very much everyone.